Okay, today we're going to talk about section 12.5, isosceles and equilateral triangles. So the first thing that we have is the isosceles triangle theorem. And this theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. All right, so let's draw a picture here to see what this looks like. Well, if I have a triangle, all right, and if two sides, we'll say this side and this side, we'll go ahead and label this triangle A, B, C. So if side AB is congruent to side BC, then also angle A and angle C are congruent. So if AB is congruent to BC, then angle A is congruent to angle C. All right, so that is our first theorem on isosceles triangles. Our second is what we call the converse of that, or the opposite. Right? And the converse says that if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So again, this is the converse or opposite of what we just talked about there. So here, again, let's start with our triangle here. We'll call this one C, D, E. So now we're saying if angle C and angle E are congruent, so if angle C is congruent to angle E, then side CD is congruent to side DE. So then CD is congruent to DE. All right, and some other parts of these triangles here that I just want us to talk about real quick is, let me draw another triangle. All right, so let's say we have this isosceles triangle here. So these sides are congruent and these angles are congruent. All right, well, these two angles at the bottom, and we'll label A, B, C. So angles A and angle C, right? So those two angles there, we call those our base angles. Angle C and angle A. All right, and then our sides that are congruent, we call those sides legs. All right, so we have base angles at the bottom. The two sides that are congruent are legs. The bottom side, right, well, if it has the base angles attached to it, the bottom side we call the base. All right, and then the last piece that we have here is our angle at the top, so angle B. And we call this the vertex angle. All right, so we have base angles, we have the base of the triangle, the bottom of the triangle, we have the legs, those are our two congruent sides, and we have the vertex angle, which is the top of that triangle. All right, our next piece here, a little bit trickier. Talk through this one. This states that if a line bisects the vertex angle, again, that's that top angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. All right, so some bunch of words there we probably haven't seen in a little while. So bisector, remember if something is bisected, whether it be an angle or a line, that means it is cut exactly in half. And perpendicular, well, if two lines are perpendicular, they form a 90-degree or a right angle. So again, if we have an isosceles triangle, all right, our base angles and legs are congruent, so there's our isosceles triangle. If a line, we'll draw a dashed line here, so if it bisects the vertex, well, remember this top angle here, that is our vertex angle. So if this line down the middle bisects that, okay, meaning it creates two congruent angles at the top here, then it also bisects this base, making two congruent links there, and where it intersects the base, it forms a right angle. All right, so a lot going on in that picture there. We have our vertex angle at the top that is bisected, okay, creating these two congruent angles. Where it bisects the base, it also creates two congruent pieces, and where it intersects is a right angle. All right, the next piece we are going to talk about is an equilateral triangle. An equilateral triangle is a triangle with all sides and all angles congruent. So this is our triangle here, and this will be triangle C, D, E, then angle C, angle D, and angle E are all congruent, and line CD, line DE, and line EC are all congruent as well. All right, now if you go ahead and flip over to the back, we're going to look at these practice problems here. Now you're going to be working through most of these on your own, but I'm going to help with the first one here so you can kind of see how we're going to get started on these types of problems. All right, so our first example here says to start, determine what types of triangles are shown in the diagram. Then use an equation to find x. Because two sides are marked congruent in both triangles, the triangles are both what? Well, in kind of this top triangle, we see this side and this side are marked as being congruent. Well, if two sides are congruent, those legs are congruent on a triangle, and same down here, this leg and this leg are congruent, then both of those triangles are isosceles triangles. So because two sides are marked congruent in both triangles, the triangles are both isosceles. All right, since they are both isosceles, and this angle here is 45 degrees, right? It is congruent to the other base angle. So that means this other base angle must be 45. Right? So our equation, 45 plus another 45 plus x, that's our vertex angle, has to equal how many degrees are in a triangle? Well, that is 180. So 45 plus x equals 180. Well, 45 plus 45 is 90, plus x equals 180. Subtract 90 from both sides. So x equals 90 degrees. All right. On that bottom triangle there, we have one base angle is y. Well, again, it's congruent to the other base angle, so the other base angle must also be y. So for that one, we have y plus our third angle, which is 120, has to equal how many degrees are in a triangle? 180 degrees. And now we have our equation. Y plus y is 2y plus 120 equals 180. Subtract our 120. So 2y equals 60. Divide both sides by 2, and we get y equals 30 degrees. So both of our base angles are 30 degrees. And on the first one, our vertex angle is 90. All right, so on the rest of these examples here, you need to set up equations, use what you now know about isosceles and equilateral triangles to finish these problems.